When you hear the words Parkinson's disease, what's the first thing that pops into your head? For most people, right, it's about movement. You think of tremors, stiffness, problems with walking. But what if I told you that one of the biggest and often one of the very first symptoms has nothing to do with movement at all? Today, we're going to unravel the hidden link between Parkinson's and something that affects a huge majority of patients: pain. So let's kick things off by looking at just how long this hidden symptom has been part of the Parkinson's story. And the answer is pretty surprising. It's actually been there right from the very beginning. And here's the wild part. This isn't some new discovery. The guy who first described the disease, James Parkinson himself, he actually wrote about pain all the way back in 1817. He noticed that these painful feelings could be one of the very first signs of the disease, sometimes showing up even before the motor symptoms that we all know about.
Okay, so that brings up a really big question, doesn't it? If we've known about this connection for over 200 years, why on earth is pain still so often missed, underdiagnosed, and undertreated in patients today? It's a puzzle that has this massive impact on people's quality of life.
And the scale of this thing is it's staggering. We're talking about studies showing that somewhere between 40 and 90% of people with Parkinson's deal with pain. Just let that sink in for a second. That means for as many as 9 out of every 10 people, pain is a fundamental part of living with this disease. This isn't just some minor side effect, it's a core symptom. Now, to even begin to solve this puzzle, we have to get one thing straight. Pain in Parkinson's isn't just one thing. Nope, it's this really complex and varied experience that can show up in a bunch of different ways all over the body. You could really say it wears many different faces. And this variety, this is one of the big reasons it can be so tough to diagnose and to treat properly. It's not like there's one simple, single target to aim for. I mean, just look at the sheer diversity here. You've got musculoskeletal pain, which affects up to 70% of people. And that kind of makes sense, right? It's connected to the stiffness and the posture changes from the disease. But as you go down this list, you get to the really puzzling ones: radicular, neuropathic, and central pain. We're talking about burning or sharp sensations that aren't from an injury. They're caused by a problem inside the nervous system itself. It's like the body's wiring is sending out false alarms. And this is where we get a major breakthrough in the case. To understand these weirder types of pain, we've got to look at the main chemical suspect in Parkinson's disease. But we have to see it in a totally new light. You see, the key to this whole puzzle is a neurotransmitter that everyone connects with Parkinson's, just not for its role in pain. Of course, I'm talking about dopamine. Okay, so here's the crucial point. We all know dopamine as the movement molecule, right? When you lose it in the brain, you get the classic motor symptoms of Parkinson's. But it has this other secret job. Dopamine is also a master regulator of how our brain handles sensory signals. Think of it like the brain's volume knob for pain. And that hidden job is super important when we talk about something called neuropathic pain. So just to be clear, this is pain that's a direct result of a problem with the part of your nervous system that processes sensations. The pain isn't coming from a cut or a bruise, it's coming from inside the wiring itself. So what happens when that dopamine volume knob breaks? Well, the brain, it basically gets rewired for pain. The pathways that are supposed to process pain just get thrown into chaos, and it leads to this state where everything is constantly being amplified. Now, this diagram, I know it looks a little complex, but it shows us exactly what's happening. It's a chain reaction. The core idea is pretty simple. It's a cascade of signals that just goes haywire because dopamine isn't there to keep it all in check. And the result is that normal feelings might get interpreted as pain, and actual pain can feel way, way more intense. Let's break it down into 3 simple steps. First, dopamine levels plummet in a key area called the substantia nigra. Step 2, that drop throws all the communication signals in the basal ganglia, which is crucial for both movement and sensation, into total disarray. And the final outcome, the thalamus, which is like the brain's main relay station for every sensation coming in, it gets totally overexcited. It basically cranks the volume knob for pain all the way up to 11 before it sends those signals to the rest of the brain. So why is it so important for us to get this? Why does understanding this brain connection matter so much? Because when you recognize that this pain is real, that it has a biological source inside the brain, well, that changes absolutely everything for patients and for the doctors trying to help them.
And if you need any proof of how critical this is, get this number. Research suggests that in 40.5% of cases, pain in Parkinson's goes completely undiagnosed, even by experienced doctors. That's almost half. Nearly half of patients are suffering from a symptom that could be treated, all because it's not being properly recognized as part of the disease itself.
So, what do we need to take away from all this? Well, first, remember that pain can be an early warning sign of Parkinson's, even before the shaking starts. Second, and this is the big one, losing dopamine is about way more than just movement. It fundamentally rewires how the brain perceives pain. Getting that link is the absolute first step to getting better diagnoses and better treatments. And ultimately, just recognizing the pain can make a world of difference for the quality of life for people navigating this disease. And that leaves us with one final big question to think about. Now that we can actually see this clear biological link between a lack of dopamine and the feeling of pain, how can we use this knowledge to completely transform the future of Parkinson's care? How do we make sure this forgotten symptom is never forgotten again?